Hello everyone, my name is Weon, the Technical and Foundry Programs Manager of Tessent Silicon Lifecycle Solutions at Siemens EDA. This is the fourth talk of this 3D IC special session, and the topic is 3D IC test challenges, trends, and solutions, an EDA perspective. Here is the agenda: understanding 3D IC market and the test challenges, IEEE 1838 for 3D IC, 3D stack test methodology, conclusion. More than Moore's law, 3D IC is going to be the new scaling approach adopted by the marketplace. There has been progress throughout the semiconductor ecosystem in bringing 3D ICs to the mainstream of design. However, only partial solutions exist for DFT. Many details, including the DFT requirements, are not fully understood yet. We conducted a lot of market researches in the last few months and collected a good amount of information. 2.5D with multiple ICs packaged side by side on a common interposer has a more relaxed test accessibility than that of 3D. 2.5D may have some specific requirements, like a package level IEEE 1149.1 compliant tab, since each die may have a boundary scan. 3D with the dies stacked on top of each other presents unique challenges for IC test, since all tests have to go through the base die. The requirements, for example, are how to make sure that the full coverage tests are consistent between a die test in the wafer and the inside the stack. Usually, we don't have enough pads that can be directly probed by the ATE. How the dies communicate with each other through a standardized infrastructure and protocol. How to efficiently perform die-to-die test inside the stack. IEEE 1838 addresses the standardized die DFT infrastructure for inter-die integration and defines the correspondent hardware and protocol. It has three important components: a mandatory serial tap port to help inter-die communication, die rep register DWR to handle the die-to-die test, and an optional flexible parallel port for transporting the die scan data in and out of the stack. However, the standard doesn't differentiate requirements between 2.5D and 3D, doesn't have an operation language, and doesn't focus on how to do the test. The 3D IC DFT methodologies consist of four categories: DFT infrastructure, wafer-level die test in package, and die-to-die test. Building a robust 3D IC DFT solution does not start from scratch. There are existing technologies providing a solid foundation for 3D IC DFT. Hierarchical DFT is scalable and extends to cover 3D IC very well, since 3D IC adds another layer of a hierarchy. Streaming Scan Network (SSN) is a newly announced on-chip DFT management solution, providing a true plug-and-play test, and IEEE 1687 compliant IJTAC to operate the DFT. On top of this, lots of new advancements are done to make a 3D IC DFT solution available. At the die level, die rep cell analysis and insertion are done to make sure these IOs that can be directly probed by ATE are instead controlled and observed by DWRs. This is to maximize the test quality for both the die test at wafer and the inside the stack. In the stack, the hierarchical DFT solution retargets the patterns created at the sub-die or die level to the package. Similarly, if there's a failure for the 3D IC testing, the failure can be reverse mapped all the way back to the sub-die or die level for performing scan diagnosis. Since you need die-to-die communication, we use enhanced taps to build the IEEE 1838 mandatory serial JTAG port for setup and access management. In order to transfer the die scan data in and out of the package, SSN natively builds the IEEE 1838 flexible parallel port by providing packetized streaming data to each die and its sub-die level for performing test pattern generation. It provides many benefits like low cost, low pin, and low power, for example, by selecting any combination of dies or cores for parallel testing. At the same time, the IEEE network language are used to operate and automate the whole DFT in the stack. Regarding to the die-to-die tests, we have to consider StarGate and SB tests, and sometimes high-speed I/O SerDes test. Hierarchical DFT provides die gray box-based solution for performing die-to-die DBG for both StarGate and SB tests. This reduces the computation resources to the very minimum. For the high-speed SerDes test, the I/O-based SN instrument is usually used and connected to the IEEE network to automate the setup and result viewing and the package. From what I said before, a set of IEEE standards are required one way or the other to make a 3D IC DFT happen. IEEE 1838, 1687, 1149.1.6, and .10. Another example is the external memory support utilizing HBM2, where its embedded IEEE 1500 protocol is integrated with IEEE network on the base die. The goal is to automate the retargeting of the HBM test patterns all the way to the package level. If desired, the user can implement a memory bits in the SoC die to connect the PHY by modeling PHY and HBMs as memories. As a conclusion, 3D IC test solution is built upon both existing technologies and new advancements. Hierarchical DFT, SSN, and IEEE provide a solid foundation. IEEE 1838 hardware and lots of enhancements, such as DWR handling, make 3D solution available. Looking forward, due to its complexity, 3D IC is a moving target with more challenges. For example, supporting heterogeneous dies implemented by different DFT vendor solutions and dies with different technology nodes. Other things include redundant I/O, LAN, and repair, and how to test TSVs during the 3D stacking process. We are actively working with partners to automate the solutions for addressing the challenges and have made great progresses, like the build-up of the reference flow. At the same time, we are calling all the industry to collaborate together to build standardized solutions for enabling the 3D IC ecosystem. Thank you so much for attending.